Good morning, everyone. My name is Constantine Tsesmelis. I'm the Technical Director of ProtosCapim, and I'm leading this proposal to FINEP. On this slide, you can see a schematic of our export barge configuration. On the top sides, we have indicated with the green units our proton exchange membrane electrolyzers. The two orange blocks indicate our 60 ton per day liquefaction units for a total of 120 tons per day production, which is stored in the hull of our export barge. Brazil undoubtedly is now a renewable energy powerhouse. We hope that our project will take us to being a superpower in terms of exporting renewable energy. This slide presents the 100 million tons of hydrogen consumed each year. Most of this hydrogen is produced from fossil fuels. It's used in refineries and petrochemical complexes, and it's interesting to note that this could well be a high-value market as well in Northeast Europe in coming years. This slide is important to view the fundamental investments for our stage 1 proposal to complete our front-end engineering design. More details here for you on funding sources, and these are explained more fully in our business plan details. This is an important slide to focus on. The 5 billion reals for our total capex covers the whole supply chain, including the export barge, all of the topside process facilities, the 50,000 cubic meter LH2 shuttle tanker that will deliver cargoes from Bahia, northeast Brazil to Europe. Our first phase of this large project is 30 million, approximately 6 million US dollars, and the investment components can be seen, and a good slide showing our future investment pathway, care of Crédit Agricole. This slide provides some more details on our infrastructure and technology. Of note on the right is a slide of a typical vendor of equipment, tanks and cargo containment systems and small scale applications. I'll leave that with you. Here we see our schematic of the missing links in the liquid hydrogen shipping supply chain and our solution, and some more information on our research and development. This is an important slide. ProtosCapim is also developing an artificial intelligence platform for the front-end engineering design that will then be developed as the project proceeds to construction and commissioning. All of the modules are going to be available, and in the future there will be links with HydroSim, which is the financial modeling simulator that was used to develop the initial concept design, and also with industry standards such as the PI system from Aviva, which will be the data process data historian that's essential to have for our project, and also to engage early with a digital twin arrangement, which again our artificial intelligence platform will integrate with. So this is a very exciting development. Here's a quick summary of our technical capacity as a consortium. I'd just like to highlight that Protos Consulting has been working in liquid hydrogen shipping now for about 4 years with Korean and Japanese uh, uh, partners and colleagues. I have a very good relationship with Ebara, who are a major Japanese pump manufacturer. They are developing an in-tank liquid hydrogen pump, which I have assessed as suitable and very valuable for the project. The other company I'm bringing to the table, to the joint venture, is Nigata, who are the world leading Japanese manufacturers and technology companies involved in uh, loading arms for LNG. And they also have a vacuum insulated liquid hydrogen loading arm development, which will be crucial, together with us, of course, selecting the most appropriate cargo containment system for the project. So, okay. So our goals are certainly there to get marine certification for the 3 key technologies. The main one, the most important one of all, of course, being the cargo containment system with its associated cargo handling system. The two go together. They are inextricably linked. So what you see here is a graphic of a typical spherical liquid hydrogen storage tank on a ship. It's just a schematic. But what's more likely to develop, and we're certainly already looking closely, is at the technologies where vacuum insulation is customized, and there is also available um, automated robotic welding for quality control with the fabricators that are trusted by the technology partners. So this is where our initial study will be focused on at the beginning of our front-end engineering design to determine the most appropriate cargo containment system and vendors in this area. Regional development in the northeast of Brazil will be impacted very favorably by our project because we have a very significant domestic hydrogen hub portion of our project where there will be flexible supplies of green liquid hydrogen available for new green industries as and when those industries can develop. It's a chicken and egg situation, and we believe we can solve that by providing up to 5 tons per day of liquid hydrogen into the domestic market. That's a large amount of hydrogen for fuel cell refueling, for fuel cell trucks, for potentially off-grid gas turbine, 100% gas turbine usage. These are what we're also contributing to the Northeast from the domestic perspective. Just a quick point on this important slide. Our green energy supply, our green power supply of 350 megawatts of power must be clean energy as defined by the European Union. Also, that needs to be part of our basis of design. And it is a complex issue because the European Union now have a specific definition for how green hydrogen and green electricity is produced. Okay, I think that yes, I'd just like to thank uh, all the colleagues and all the help I've been given with my language difficulties. However, let's invest in the future. Let's invest in Brazil. Undoubtedly, I hope that the evaluation committee will find my comments of value, and I'm available at any time to answer any further questions that may need answering. Thank you very much for your attention.